5, Lesson 1 in Geometry. We are going to be talking about ratios and similar polygons today. So starting with the warm-up, we want to list 5 ways to prove that two triangles are congruent. Remember, they are SSS, SAS, AAS, ASA, and HL. So if I have triangle QRS is congruent to triangle ZYX, identify the pairs of congruent angles and congruent sides. For angles, we would say angle Q is congruent to angle Z, angle R is congruent to angle Y, and angle S is congruent to angle X. And then for the sides, we would have QR, remember this little bit, would correspond to ZY, so it is congruent to ZY. Then we would have RS is congruent to YX. And last but not least, we would have QS or SQ, whichever one you prefer, is congruent to ZX. Okay, so with proportions for 3 and 4, remember you're just going to cross multiply. So 2 times 3x minus 3 equals 8 times x minus 3. So then when we distribute 2 times 3x is 6x, and then 2 times negative 3 is negative 6, and then 8 times x is 8x, and 8 times negative 3 is negative 24. So then we have to solve this equation. I would probably subtract the 6x just so that we can keep the x positive. So that would give us negative 6 equals 2x minus 24. Then to get the x by itself, we would have to add 24, which I'm going to have to do this a little bit. So that would give us 18 equals 2x. And then when we divide by 2, we get that x equals 9. Okay, so we do the exact same thing with number 4. We are going to cross multiply. So we would have, and I'm going to write it over here, 77 times x minus 6 equals 42 times 2x minus 14. 14. So again, we are distributing. So 77 times x is 77x, and 77 times negative 6 would be negative 462. And then 42 times 2x would give me 84x, minus 42 times negative 14 would give me negative 588. So then to solve this equation, again, I would probably move the 77 just so we can keep the x's positive. So when we subtract 77x, that gives us negative 462 equals 84 minus 77 is 7x minus 588. Then to move that 588, we would have to add it because it's the opposite of the negative. So then negative 462 plus 588 would give us a positive 126 equals 7x. And then when we divide by 7, we get that x equals 18. Okay, so 5, make a list of any things that you believe are similar, and this could be anything. Some people have said like pens or pencils are similar. People have talked about different foods that are similar, really anything that you think is similar. And then a quick recap of the signs. This first one is, of course, an equal signs. This middle one, it means congruent. And the squiggly one means approximately. Okay, so figures that are similar have the same shape but not necessarily the same size. So if you notice with that little symbol, that is our similar symbol. So if we look at the triangles, triangle 1 and 2 are similar because they have the same shape and are just different sizes. So that's when we write our similarity statement. And if you want to note it to yourself, similarity statement. But we know that those shapes are similar. But if you look at 1 and 3, they are not the same shape, and they are obviously not the same size either, so they are not similar. So, two polygons are similar if and only if their corresponding angles are congruent and their corresponding sides are proportional. So, if you notice with all of these, or with the picture, A and E are the same, D and H are the same, B and F are the same, and C and G are the same. They're all congruent. And on top of that, the sides A, B to E, F, that'd be 6 to 12, B, C to F, G, we have the same ratio between it, because to go from the small one to the big one, we multiplied by 2. To go from 5.4 to the big one, we'd multiplied by 2. And same with 4 and 8 and 5 and 10. So it's the same ratio every single time because it's proportional. So when we are looking at similar polygons, we want to identify the pairs of congruent angles and the proportion of the corresponding sides of the polygons. So if you notice with these triangles, we have congruent angles here and here, here and here. And then if you remember with triangles, if two of their angles are the same, then their third angle has to be the same. So we know all of the sides are congruent. So then to make sure that the sides are proportional, you have to set up a little ratio. It does not matter if you go big to small or small to big. Personally, I just it depends on the way it's given to me. But with this one, if I had, let's say 1.5, that's going to correspond to the 0.5. So I would say 1.5 divided by 0.5 is 3, which means that my big shape is 3 times the size of my little shape. But just to make sure, we have to verify that all of these are the same proportion. We need to check 3.3 divided by 1.1, which is, again, 3. So these are similar. So we can say triangle MNP is similar to triangle TQR. Okay. For the next triangles, we are going to identify the congruent angles and corresponding sides. I guess what I should have said with the first one is that they told us that they were similar, so we didn't necessarily have to check the sides, but it's always good to just kind of verify real quick. So we want to identify the congruent angles and corresponding sides. So again, if we notice, we have a 90-degree angle there and there. We have a 59-degree angle there and there. And we have whatever that one would be, which real quick, just because I'm curious, would be 31 degrees if you care. So with that in mind, double checking the ratios, like I said, it's always good just to kind of quickly check. BC is 6, and BC corresponds to the yellow-blue, which is 3. So that would give us a similarity ratio of 2. And then if we look at, let's say, this 10, that's going to correspond to the 5, which is also 2. And if you look at the 11.6, it's going to correspond to that 5.8. And again, 11.6 divided by 5.8 is, wouldn't you know, 2. So then we would say triangle ABC is similar to triangle JGH. Okay, because again, you want your corresponding parts. So since I went gray to yellow to blue on the first one, I have to go from gray to yellow to blue on my other one. Okay, so a similarity ratio, which I've said a few times now, but a similarity ratio is the ratio of the lengths of the corresponding sides of two similar polygons. So if you look at the two triangles that we have side lengths of 3 and side lengths of 6. So if we were to go and write a similarity ratio of triangle ABC to triangle DEF, then I would put triangle ABC on the top, and I would put triangle DEF on the bottom. But that means that with that similarity ratio being 1/2, that the small triangle is half the size of the big one. Now, if I decided to go it the other way and go big to small, then that is fine as well, but you want to make sure that you put it in the correct spot. Okay, so moving on. Writing a similarity statement is like writing a congruent statement, so be sure to list the corresponding vertices in the same order, okay? We've talked about it before, but you have to have your corresponding parts together, otherwise it just doesn't work out quite right. So now we want to identify whether or not the polygons are similar. So we have rectangles A, B, C, D, and E, F, G, H. So when they name them like this, that is kind of your hint of what should be corresponding. So if we have AB, that's going to correspond to EF. So to write a similarity statement, that would be, or sorry, not similarity statement, to look at the ratio, we would want 6/4. And I didn't actually identify the pairs of stuff, but A is congruent, angle A is congruent to angle E, angle B, write them all out. But B is going to correspond to angle F, C is going to correspond to angle G, and D corresponds to angle H. So with that in mind, AB, and if you want, you can even put the letters if it makes it easier for you, but AB over FE would give us 3/2. And where you have to be careful is if you start with AB on the big rectangle, then your next one has to also start on the big rectangle. So I have 9 over, and if you want to label, you can. And then this is going to correspond to FG, which is 6. And when we simplify 9 over 6, it also simplifies to 3/2. So my similarity ratio is going to be 3/2. If you did it the other way, it would also be 2/3, depending on which way you went. But then my similarity statement is going to be rectangle, and actually with rectangles, we do sometimes just draw a rectangle. But rectangle A, B, C, D is similar to rectangle E, F, G, H. Okay? With the next one, we want to determine if they are similar, and if so, write a ratio and a statement. So with these triangles, we have that the sides are 10 and 10 and 5 and 5. But unfortunately, we don't know the angles. So to check these angles, with triangles, the angles are actually, they have a relationship with the side lengths. So if this side is 10, and this side over here is also 10, then their angles are going to be congruent. So because their angles are congruent, then you can figure out what it is by subtracting from 180, because 180 minus 36 that we know gives us 144, but that 144 has to be split evenly between two angles, so we would divide by 2 to get 72 degrees for each of those angles. Now, knowing this, that means that this angle would also be 62 in this little triangle. And if both of those are 62, then that means that the top angle would have to be 56 degrees because you're subtracting from 180, remember? So notice these are not similar because the angles are not the same. Okay? Even though they do have a similarity ratio between their sides, it doesn't matter because the angles aren't the same. So when you work with proportions, be sure that your ratios compare your corresponding measures. That's probably people's biggest issue that they have with corresponding and similarity and stuff, is that they mess up the corresponding parts and then they mess up their final answer. So looking at an application of this, we want to find the length of the model to the nearest 1/10 of a centimeter. So looking between the racing car and the model car, we have the same lengths. Even though they are different units, meters and centimeters, as long as you have two of them, it is totally fine. So again, you can go big over small or small over big. It does not matter. But whichever one you choose, you have to stick with the entire time. So let's say I started with my big one. I'm going to start with this 5 meters. Okay. And if I have the 5 meters, the corresponding piece is this x. And then if I go back to my big one, we have 1.8 over 6.3. Okay. Keep in mind, you could set this up a bunch of different ways. You can have 5 over x equals 1.8 over 6.3. You can also even set it up to where you put all of the dimensions of your big one, like 5 over 1.8, and then the corresponding parts on the little one like that. Either way, you'll get the same result. But when you do this, when we multiply 5 times 6.3, that gives us 31.5 equals x times 1.8, which is just 1.8x. So then when we divide by 1.8, boop, we get that x is 17.5. And keep in mind that this is going to be in centimeters because the 5 was meters and the 1.8 was meters, and the x is centimeters because the other little one is centimeters. Okay? And if you want to set it up and do it through the other way, you totally can, but you will still get 17.5 centimeters. So a rectangular boxcar is shown. A rectangular model of the boxcar is 1.25 inches wide. Find the length of the model to the nearest inch. So again, we can set this up numerous different ways. It's kind of up to you. If, let's say, we'll set it up the other way. So we'll do all of the boxcar dimensions, 36.25 feet, divided by 9 feet. Okay, and then my corresponding pieces are going to be the x inches and 1.25 inches. If it helps you to keep the units in the proportion, by the way, at least when you set up, that's totally fine. I want you to do what works for you. So if it's helpful so that you don't forget it, totally use it. But 36.25 times 1.25 gives us 45.3125. And then 9 times x gives us 9x. So when we divide by 9, we get that x is 5.034, blah, 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 blah. Just kind of keeps going. So since we're going nearest inch, though, nearest inch is going to be this 5. And so when we're rounding, we look at what's directly next to the place we're trying to round to. That is a 0, which tells me to round down. So my model is about, and this is where you can use your approximately, 5 inches. Okay? So, real quick, transformations, we're just going to kind of talk about it briefly. The types of transformations that we have talked about are rotations, reflection, dilation, and translation. Okay? Now, with that, thinking about the shapes that are result after you make these transformations happen, there are 3 that make congruent figures. They are rotation, reflection, and translation, because when we do these, none of the shapes change. Rotation just rotates the shape, reflection just reflects it exactly as you see it, and translation just shifts it up, down, left, or right. So thinking about transformations that make similar figures, remember these have to be different sizes, and that only leaves dilation. Our only similar figure transformation is dilation. So last but not least, are circles similar? The answer is yes. All circles are similar. And P.S., that circle with the dot in the middle is our symbol for circles in geometry. So your homework is listed on page 469 of the textbook. If you have any questions, please feel free to ask either in the comments below or however you can reach me. If this video was helpful or anything like that, Please give it a like and a thumbs up, and subscribe to the channel so that you can get notifications when we make more videos. Thanks for watching, and we will see you later.